Okay, this is solving quadratic equations using square roots. If you remember from 9.2, 9.2 was all about solving using graphing. Okay, so we're solving the same problems, but this time we're using square roots instead of finding where our x-intercepts are. Okay, so our x-intercepts of our graph told us where our solutions were, but now we're going to be using something called the square root method. And if you look at the formula ax squared plus c equals 0, you'll notice that it's because we can use this form because our b value is going to be 0. Okay, our b value is 0, so it's taken out of the equation, so we just have an a and a c term. Okay, and then when we're solving these types of equations, it's going to end up being x squared equals a number, okay? Or our squared term equals a number. If this d value is positive, then we're going to get two solutions. If our d value is 0, then we're going to get one real solution, which is x equals 0. And if our d value is negative, we're going to get no solutions because we'd be taking the square root of a negative number. And this we cannot do. All right, so let's go ahead and take a look at some examples for letter A. So in this example, we're going to follow two steps for these equations. Step number 1 is you have to isolate your square term. Okay, now our square term is whatever's being squared. So in this first example, it's just x squared. The 3 here, guys, is not being squared. It's not in parentheses, okay? So we have to isolate, or we have to get rid of that square, or that 3 as well, okay? So the first thing we're going to do is add 27 to both sides. Once we add 27, we now have 3x squared equals positive 27. Once we have that, then we just divide by 3, and then we're going to get x squared equals 9, because 27 divided by 3 is 9. So we've finished step number 1. We've isolated our square term. Our square term is completely by itself on one side of the equation. Could be the left side, could be the right side. Then after we're done with that, the second part of these problems is to take the square root of both sides. So we're going to take square root of both sides. Now what this means is we are literally going to put a radical symbol over both sides of the equation. Now the most important part of this is that you add a plus or minus symbol. This plus or minus symbol means that we can have a positive and a negative solution, okay? Now the reason we do that is because when we take the square root of x squared, the square root and the squared will cancel. We'll get x equals, then we have the square root of 9. Now the square root of 9, if you remember, if we square 3 and square negative 3, they'll both be 9. So when we take the square root of 9, it has to be a plus or a minus 3, because we can have positive 3 or negative 3. So these are our two solutions. Okay, x equals positive 3 and x equals negative 3. Let's do another example. Let's do b, okay? So when we're doing b, we start by isolating our variable, or our square term. Our square term is x squared. So in order to isolate him, we would add 10 to both sides. We're going to get x squared equals 0, because negative 10 plus 10 gives us 0. Once we get that 0, then we would take the square root of both sides, add our plus and minus. We're going to get x, because the square root and the squared cancel, equals the square root of 0, which is just 0. Now, the plus or minus here goes away because 0 cannot be positive or negative. It's just 0. And this has exactly one solution. Okay? So when x is equal to 0, there's going to be one solution here. All right, so let's see one more example. Let's take a look at D. So we've got negative 3x squared equals negative 75. Now, sometimes people tend to freak out because they're like, oh, there's a negative over there, okay? The negative is important, but you have to wait until you've isolated your square to see whether that d value that we talked about in the beginning is going to be negative or not. So in this case, step number 1, isolate the squared term. Our squared term is still x squared, not the negative 3. We would divide by negative 3 to both sides. And when you divide by negative 3, you're going to get x squared equals positive 25. So now our d value, our value on the right-hand side was a negative. Now it's a positive. So when we take the square root, we're still fine. We're still Gucci. We get x equals plus or minus the square root of 25 is just 5. So we still get two solutions here, okay? Now, in the last example, I want to show you guys. we are going to get no solution, okay? And I want you to pay very close attention to what has to happen in order for us to get no solution. So if you go to the next page, we're going to take a look at E. We've got x squared plus 12 equals 10. In this case, we would subtract 12 from both sides. We're going to get x squared equals negative 2. And then when we take the square root, look what happens. We put our plus or minus. We're going to get x, not x squared anymore, just x equals plus or minus the square root of negative 2. Now there's no number, no real number, that when we multiply it by itself, it gives us a negative 2. So this has no solution. Okay? All right, and then when we move on, we're going to jump to solving quadratic equations using square roots. These are a little bit different. Now, how these are different is because it's x minus 1 inside the square, right? So that is still part of our squared term, but we're going to have to set up two equations here, okay? And I'll show you what it looks like. Now, our square term is this whole thing squared, so if it's isolated, which it is, we can just take the square root of both sides. So we're going to take the square root of both. These will cancel out. We'll get x minus 1 equals plus or minus the square root of 25, so we're going to plus or minus 5. Now, we know that our answer equals positive 5 and negative 5, but our answer is now x minus 1 equals that. So we have to write two different equations. One's going to be x minus 1 equals positive 5, and x minus 1 equals negative 5. Once we write both of those down, you know that you would just add 1 to both sides. X equals 6. Add 1 to both sides. X equals negative 4. So our two answers are 6 and negative 4. All right, let's do another one like that. Let's go ahead and I would like to do C, okay? So in C, we've got 4 times x minus 3 squared. This is our square term, so in order to isolate him, we're going to divide by 4. We divide both sides by 4. We've got x minus 3 squared equals 9 over 4. We would take the square root of both sides because we've isolated him. We've got x minus 3 equals the square root of 9 over the square root of 4. This is now 3 over 2. Don't forget your plus or minus. So we've got x minus 3 equals a positive and a negative 3 over 2. Now, when we're solving this one, remember, whenever there's more than one term, not just x equals, right, you have to set up two different equations. So here, we're going to break it down into two. We're going to say x minus 3 equals the positive solution, so 3 over 2, and x minus 3 equals the negative solution, negative 3 over 2. Once we have that, we just go ahead and solve. You would add 3 to both sides. So we got x equals 3 over 2 plus 3 over 1. Common denominator, x equals 3 over 2 plus 6 over 2. That gives us 9 over 2. And the other one, we've got to add 3 to both sides. Add 3. We got x equals negative 3 over 2 plus 3 over 1. Common denominator, x equals negative 3 over 2 plus 6 over 2, which is going to give me positive 3 over 2. So our two answers are 9 over 2 and 3 over 2. All right, so as you notice, before we were just saying x equals our plus or minus solution, but now whenever you have an expression, not just x on the left-hand side, you have to set up two equations. All right, let's go ahead and move on. These next few, we're not going to get a super convenient answer. We may get a radical, and we're going to have to simplify that radical. So for A, we're going to add 13 to both sides. We're going to get 4x squared equals 28. Divide by 4, divide by 4. You're going to get x squared equals 7, okay? So we've isolated our x squared term. Then you just take the square root of both sides. You're going to get x equals, and then you've got plus or minus the square root of 7. Now, this does not simplify because 7 is not a perfect square, nor does it have factors that are perfect squares. So this is how we're going to leave our answer. All right, let's go ahead and we'll do C as well, okay? So in C, we would add 2 to both sides. We're going to get 5x squared equals 2. Then you're going to divide by 5, divide by 5. We're trying to get that x squared term by himself, so x squared equals 2 over 5. And then we just go ahead and take the square root of both sides. Don't forget your plus or minus, so x equals plus or minus the square root of 2 over 5. Now, we cannot leave our answer like this because it's not in simplest form. You cannot have a fraction underneath a radical, so we have to write it as x equals plus or minus the square root of 2 over the square root of 5. Always, always, always get that radical out of your denominator, so multiply by the square root of 5 to both the numerator and the denominator. We're going to get, finally, that x equals plus or minus the square root of 10 over just 5. All right, and last but not least, last example, which is D. In D, we would have to add 30 to both sides. We're going to get 3x squared equals 34. Divide by 3, x squared equals 34 over 3. Take the square root of both sides, add your plus or minus. X equals plus or minus the square root. Let's break up that square root 34 over the square root of 3. And let's try to simplify first. So 34, we're thinking like what factors go into 34 that are also perfect squares. The only factors of 34 are 17 and 2, and neither of those are perfect squares, so that's kind of has to stay put. But we can multiply by the square root of 3 over the square root of 3, and we're going to get, this is going to be, well, let's do it. 34 times 3. 3 times 4 will give me 12, so bring down your 2. Bring up your 1. 3 times 3 is 9, plus 1 is 10, so 102. So we've got the square root of 102, which also has no factors that are multiples of, or perfect squares. And then over the square root of 3 times the square root of 3 is the square root of 9, which is just 3. So this is our final answer. We stick a plus or minus on it, and we are Gucci. Let's take a look at our